Good morning. It's 0 centigrade, 32 Fahrenheit for my North American colleagues. Well, at least not Canadian ones. Back to working on this Lewis Shaper, and one of the things we're turning this down to 762, I believe. I'll double check the measurement, but we're going to be turning this one down, and we've already threaded it half 13. And this is going to be the handle on the right hand side. So we've got some other work to do on this, adding a key and a few other odds and ends, but we'll bring you back and take you through most of that. I'm glad I double checked. I just went ahead and measured that bore again, and it's not perfectly round, but and it's in that large housing is why I couldn't mill it super well. It is 777 is where we're headed, so we are just under 200 thousandths to go. I've got it set and zeroed out so you can see that the touch DRO is ready to set at the starting dimension, and then we will get this turned down. Love the touch DRO for me. One, being able to port back and forth, but two, it helps you keep your head straight. Dials are great, but man, you can get lost quickly if you're not paying attention. Okay, let's take a 30 thousandths cut here. It's early. And we're all set, checking the feeds. It's a Monday morning, I'm not working. So we are just relaxing. Grandkids will be here around 4 o'clock, get off the bus. That's my job. And I get a hug for it, so there's no problem there. Been working from home for about 2 years now, so getting quite settled in to helping with the grandkids. My daughter doesn't have to stress. Son-in-law is working from home part-time and working full-time at the office, so it just helps them, you know, that one little step of the day to get the kids off, and plus I get to see them. And those of you that don't have grandkids, that are parents or whatever, grandkids are way better. I'm just going to say that out loud because it's true. Love it on the Harrison lathe here. It is such a good manners and such a good friend. It's very patient with me. Its capabilities are way more than I have, but at the same time, it's very generous and kind with its time. Nothing special tool insert. Inexpensive one from overseas. At the same time, it seems to work out pretty well. I like the little diamond shape on these. Looks pretty well. Getting in the corners. Nice. Okay, final cut. Let's see if we can bring it in. We're using balanced cuts, as I've mentioned on previous videos. Thank you to John's Workshop, for giving us a good lecture on that. The carbide seems to like it better. It likes to get in underneath and dig. So thank you for that. It has helped me, as have so many other of my YouTube teachers. I take it seriously. I try to learn, and from that standpoint, thank you to all of you for whatever contribution you make. I was making about a 30 thousandths cut. This one's closer to 20. And you can see that there's a definite difference in the chip it's breaking. It's still a little bit longer squiggly than what it was, but this is kind of where I landed. Where I was getting into trouble was trying to do that 1,000ths feathering cut, 2,000ths feathering cut, and it just was junk. It wasn't turning out very nice. High-speed steel, I probably would have been fine. With the carbide, with the nose radius and everything, it just didn't like it. So, thank you. I appreciate it. It's immediately helping this kind of short point. I could play with the feed on this one a little bit, but again, this is not exposed. It's actually a little bit of rough surface would be great to trap some oil in it. Okay, we'll feather it up. And size. Shouldn't be really hot. Obviously it's going to grow with the heat, but not a great surface finish, but also again not bad. Oh, it's barely even warm, which is good. That tells me the tool was actually cutting and not pushing. Okay, 777. You can see that we are pretty much right there within a half a thou. And again, I didn't calibrate the mic. Hopefully you can see it okay. So that part was done successfully. Now, is it going to fit? Don't know. We've got some more work to do, but I'm going to go ahead and break this edge here, and then we'll break it out and then have a size check fit, and we will bring you back. Ah, the joy of working on home projects. So we've got the housing board, good fit, a little bit over, but this was egg-shaped internally, so the fit here you have, I had to relieve it just a little bit, but it's got just a little bit, but it's supposed to do this all day, right? It's supposed to sit and rotate freely, so that's not a problem. Okay, this one is to the dimension, and when you take the two out, it fits nicely into the housing. There we go. Put the ratchet out. Everything's fine. Good tight fit. The combination of getting this on a center line and then this is on a center line, yeah, I got an egg-shaped housing. So I'm going to have to relieve the housing just a little bit. It won't affect anything. The relationship is between this right here and this gear and this is going to be piloted on the shaft. And then this relationship to here, as far as the ratcheting mechanism, the size of this bore really is irrelevant because this gear is being supported on the shaft. So it's floating, this housing is floating around the outside, so this won't make a big difference. But I just... Okay, sorry, this little tripod's giving me a heart attack here. We've got the housing mechanism set in. What I'm going to do is I'm going to pick up the center for that one, and then we're going to touch it up just with a boring head, just to clean up that bore and make it round because it's egg-shaped right now. Okay, saying hello to the Bridgeport boring head. Picked this up for a good price, and it's awesome for me. Okay, I know there's a whole lot other levels up. You go to the trees and all that other wonderful stuff, but as far as for me, it does very simple work, very reliably, and that's all I need. Okay, let's get down to the setup. Okay, we've kind of roughly dialed it in, and what is interesting is going all the way down. Let me back that off just a hair. There we go. So I've got the depth stop set to prevent me from going all the way and crushing on the bottom, so that should leave me just a little bit. And then we've got it dialed in. Now, what's funny is if I go in to these spots that I marked before, like right here and over here, yeah, those are the egg-shaped spots. So from that standpoint, we are going to dust this off just a little bit. You can see it's hitting right there. And then change this up just a little bit. Okay, right there it's clear. A little bit of backlash in the boring head, no big deal. Alright, so right there, I'm just going to lock the quill and I'm going to turn that around. So that's the high spot, and I can see daylight around the outside edge, probably 5 or 10 thousandths. And then right there it gets tight again. So we will bring this up. Let's just do a quick test cut. Make sure we're not banging into anything. Okay. Release that. There is a precision fine feed down on a Rockwell. There we go. Yeah. I'm just doing it by hand here because it's not super critical. Okay, we're down. Okay, so checking the witness marks. I've got just a smidge here. And everywhere else it appears to be clear. So, okay, we will continue here. So I am going to feed in. Let's go 5. Let's see how that works. I'm going to adjust the quill for just a little bit of drag. It's very nice on the Rockwell. You can set just a little bit of drag for it. Could have done this on the lathe, no problem, but figured I'd just do the boring head setup. I haven't really done much with it in videos, so you haven't seen it before, obviously this is just a beginner's look at it. Okay. I mean, I could have set it in the 4-jaw and offset it, but we didn't. Alright, do another 5/1000ths. Let me check where I was hitting. Okay, just a smidge right here. And just a little bit over here. Okay, I think we're getting, this should be more close to getting a real bite. Okay, over here. Mushroom. Let's take your hands free so I can show you up close. There we go. There we go. Okay, you can see it's getting just a little bit on that edge. Cleaning it up, it's not quite as dull. And a little bit over there, but mostly at the top, not much at the bottom, so I'm pretty sure it was mushroomed. Yeah, it's not even getting anything on that back wall. Okay, let's go with another 5. Let me get this down closer. A little bit more of a hit. You can hear it popping in 2 spots. Getting a nice ringing effect. There's the bottom. We just found the other edge of it. Alright. You can see that in the back corner. We're getting square on that one. And that arc runs around to right about here. So we were not that far off on what we were guessing. Okay. So not super critical here, but let's interesting. I'd like that to be all the way up and down, but it definitely was egg-shaped. Another 5. There's the bottom. Okay. I'll just take the stand over with me this time. Get out of there. And you can see that it's dusting off that one side still. And it's not all the way up and down yet. So I think the outer edge of this thing was egg-shaped. Probably, who knows how they did it, but we're getting a fairly consistent line, so the taper was fairly even. Okay, since we're here, talk about this up here. Okay, this is the fine feed on a Rockwell. What you have right here is this little locking right here. Inside there is a brass, or yeah, let's say a brass or a bronze dog. It's a cone. So when I tighten this up, it's loose right now. I tighten that up, that will lock this little worm gear in, and then this knob will do the fine feed. So this is an awful knob. It's horrible. It's what they had, but it is a very good fine feed. So I don't think I need to use it on this one, but if I were doing a really precision little boring job, I might consider it. But this is actually probably going to ultimately be replaced by power feed right here. There's a little one that Double Boost put up on his, and I think, I bought the parts and I just haven't done it yet. But I think that'd be nice. It's just basically a little gear drive for it, and it should work great. Okay, I'll bring you back. Okay, for those who haven't used one before, this is what I'm using on this Bridgeport one. Very, very big numbers. You can see them. They're really nice to use. Alright, so I'm going to take another 5, and then we're probably going to call it with this one. I think that should have cleaned up most of the mess that we had. Okay, so I'm going to bring it down just a little bit. I'll change your camera angle so you can see that back wall where most of the action's happening. I think I've got that light clearance. In good shape. Yeah, the sound's changing. The parting line is right to about here now, so it's actually coming in more into being actually a real circle now. Getting a little more on the back wall. I guess you can see. There we go. Alright, so after the boring, get a nice floating fit, if you will, and just going to do this to simulate the gear train. So from here, right, no effort at all. Changing directions. Okay. Yeah. And again, I need to do just a little bit of finesse, but I think that's a good fit. I think we've resolved the issue of the egg-shaped element.